Please make sure you have your copy of the assignment Chemical Properties of Elements, a short little experiment to look at how the arrangement of elements on the periodic table is related to their chemical properties, the way that they react. So we're going to first start with a little demonstration video. I'm going to show you the reactions of several elements from group 1 and 2 on the periodic table when they're combined with two different substances, ammonium carbonate and ammonium phosphate. I listed the elements and I wrote out their electron configurations for you so that you could look at those. And then we'll record whether or not there's a reaction or not a reaction when we combine these substances. Again, the elements that we're looking at are in groups 1 and group 2 on the periodic table. Groups are columns that go up and down the periodic table, and there's a reason why elements are arranged that way. How elements are arranged on the periodic table was first determined by how they react with similar substances. So here's the first part of the data table, just looking at lithium, sodium, and potassium. These are part of compounds that I use to make solutions like strontium nitrate, a compound that dissolves in water, or lithium nitrate. That's where I got these substances. That's where the elements are coming from in this part of the table. Here I've got two solutions made with ammonium carbonate and ammonium phosphate. They're both clear, colorless solutions because these substances are soluble in water as well. What we're looking for is a reaction that causes something to form that's not soluble in water, a cloudy mixture. And so here I have already put the lithium mixtures into these two caps, sodium in these two caps, potassium in these two caps, and then I'll put carbonate into these three and see if there's a reaction. Carbonate, carbonate, and carbonate. Okay. According to what I see here, there's no reaction, there's no change in the appearance of these mixtures. The lithium and the carbonate, the sodium and the carbonate, potassium carbonate, no reaction. Try that with the phosphate. Okay. Phosphate and lithium, phosphate and sodium, phosphate and potassium. Similar result. The lithium and phosphate, no reaction. Sodium, phosphate, no reaction. Potassium, phosphate, no reaction. What's going on in these mixtures is that the parts of the compounds are all mixing around and seeing if they can combine together to form new substances, and nothing seems to be happening here. So let's go on and look at the other three elements, the compounds containing those, magnesium, calcium, and strontium. And I'll put the carbonate into those three, magnesium, calcium, strontium. Okay, there's something different going on here. It looks like it's getting cloudy. So that was the carbonate. And now I'll try with the phosphate. And magnesium, phosphate, calcium, phosphate, and strontium. Cloudy. So these three, magnesium, calcium, and strontium, show a reaction, a clear, colorless solution combined with these elements turned cloudy. So the parts of the compounds that these elements came out of, and then the parts of the other two compounds, they all combined and they rearranged, and new substances were formed that don't dissolve in water. That's why we see the cloudy precipitate reaction there. So we'll record on your data table which ones showed reactions and which ones did not. And then we'll look and see what does that have to do with the way these elements are arranged on the periodic table, and in particular the electron configurations of the elements too. What do they all have in common? Then on the flip side, I'm going to ask you to try this yourself, make a prediction about another element that was not tested, the element barium, which is also part of one of the compounds that I could have used on this side of the table. If you tried to combine barium with the carbonate and the phosphate, what would you predict would happen and why?